So I wanted to talk a little bit about the Vera Rubin telescope that's coming online soon. And it's a survey telescope, meaning it takes a picture of the entire sky every 3 days, over and over and over again for the next 6 years. And what they're going to essentially get is a movie of what the night sky is doing every 3 days. And they'll notice that things move around, they'll notice when things change. But I was watching a uh, YouTube video about the discovery of a black hole nearby and how one of the things that lone black holes do is gravitationally lens the background sky. One of the things that the Vera Rubin Space or Survey Telescope may end up finding is the rippling of the field of view by the estimated 100 million stellar mass black holes that are in our galaxy. So what you'll see is this kind of flickering of the entire galaxy as these black holes travel through the galaxy and bend space-time around them. It's going to be a wild pattern. It might look something like the top of a lake on a slightly breezy day where it's not peaking and there's no white caps on the water, but the water ripples as opposed to being completely calm. And we're going to look at that. We're going to look at the rest of the galaxy and really the rest of the universe through that rippling. The other thing that, because it's taking sequential pictures, we're going to be able to actually assemble all the different perspectives. Because while it's creating this series of images, we're moving through the galaxy ourselves. So our point of view will change in relation to that, and being able to use geometry and computer technology will then be able to really assemble a giant 3D map of our galaxy. Parallax is the idea that when you can judge the distance to a particular object if you view it from two different locations and measure its apparent distance. If you know the baseline of the triangle that's formed by those 3 points, you can know the height of that triangle as well. It's geometry. Now what we'll be able to do is do that for the several million points of data that the telescope is going to collect. We're going to get a 3D movie of our galaxy and the universe around us over the next 6 years. We're going to know where we live. What a idea to think that when Einstein created general relativity, he absolutely and without a shadow of a doubt thought that the universe was a static place that consisted of our galaxy alone, and that it was static. And then they found there were other galaxies. Hubble and others found that there were other galaxies. And then what they further came to understand is that those galaxies were moving away from us, placing us in an expanding universe. And Einstein actually had a trouble with this idea. And it led to the greatest blunder of his career. And that was the cosmological constant, which he used to hold the universe still to counteract the apparent expansion of the universe, because he simply couldn't believe it. that number that he just chucked in there to balance out his equations to suit his preconceived notions of what the universe was ended up actually being an exceptionally useful number, and also one of the numbers that's extremely important to explaining why the universe appears the way we see it does. And that idea is an absolutely astoundingly beautiful one. I urge you to look up. Thank you.